Hi, I'm Sophie, and this is my spring oscillation lab. So to outline what I'll be going through, I'll describe the purpose of the lab, some things to know to help with tracker and coding, and how the code compares the graph of my observed motion from tracker and the predicted motion that I created from the code. I'll answer the what does it mean questions, and then I'll include potential errors in my conclusion. So the purpose of this lab is to understand and predict the spring oscillating motion using the energy principle and seeing if the model matches the energy principle. Spoiler alert, it does, because the change in energy equals 0, because the kinetic energy and the potential energy cancels out, and the predicted and observed motions are similar. Some things to know beforehand is Newton's second law, which is F equals ma. The net force of the mass, which is the force of the spring plus the force of gravity. The force of gravity is in the negative y direction, and the spring is up towards where the spring is attached to. Change in energy of a system equals the work of the surroundings plus Q. The system is that I took was mass, spring, and the earth, which made the energy equal delta K plus delta potential gravitational energy plus delta potential spring energy, which all equals 0 if it follows the energy principle. What I put into tracker, I put this video in and I calibrated it as 0.7 meters. The final time was 8.54, which I will put in my code, and I'll show where I put it. That was my initial position. Initial velocity is 0, and these are the X and Y graphs. Using what I made in tracker, I calculated T, the period of oscillation, which was 6.83, and then the force of gravity times the spring force I used to calculate L0, which is 0.123 meters. Here's my coding. This is the initial position vector, gravitational acceleration. This is the mass of the ball. This is what we calculated in the previous slide. I used a small deltat in order to just to show how tracker went. Here is the S formula, kinetic formula, and then potential energy formulas. And the total energy should be 0 if it follows the energy principle. T is less than 8.5 because that was my ending time slot. Coding continued. This is similar to what I had before. E should be 0. Delta K should be K final minus K initial. This is just the velocity update formula and position update formula. And that's the spring update formula as well. Here's the final energy graph from the coding. As we can see, delta E is 0. The red represents the gravitational potential energy. The green is the potential spring energy, and the blue is the kinetic energy. When we compare the X and Y, the X is pretty spot on with the model and experiment, but the Y position is slightly off, and I'll explain in my errors why that is. So what does it mean? For the model system, is the energy principle satisfied? Delta E is at 0, so yes, it is satisfied. And estimating the X oscillation period, I took it from the top of the beginning of one oscillation period to the end of it, which was, I estimate about 1.4 seconds. And for Y, I estimate about 1.2 seconds. When comparing these two, they're very similar. And it's possible that they could be the same, and it might just be because of my error in the Y position, or my estimation is off. So potential errors for why my Y-axis is not exact. When calibrating my point of mass or center of mass, I might not have clicked the exact center of the mass. As you can see here, this one's slightly off, for example, when doing the whole thing. And not calibrating the Y-axis properly. This I had to change multiple times to get it as close as possible. So it's possible that I could have kept going to get it more accurate. Thank you.